You're listening to the Archaeology Podcast Network.
Hello and welcome to the ArchaeoTech Podcast, episode 207. I'm your host, Chris Webster, with my co-host, Paul Zimmerman. Today we talk to Dr. Markus Eberl about his team's efforts to analyze micro-debitage using particle analysis and machine learning. Let's get to it. Welcome to the show, everyone. Paul, how's it going, man?
Okay, I think I'm really sleep deprived, but happy, I guess. Came back from Saudi just over a week ago, and I've got another week and a half or so before I head back.
Oh man!
We're gonna have to find some more co-hosts for you because my schedule is awful lately. How you doing, Chris?
Well,
and where are you?
I'm doing all right. Yeah, I'm doing all right. We're in northwestern Washington. If you see a temperature map of the United States, we're the only blue part that is not over 100 degrees. I mean, in fact, it's 70 degrees right now. The high is 72, and I am loving it. I don't ever want to leave here just because of that, given where everybody else is doing. So just so everybody knows, too, we are recording video. So if you want to watch this rather than listen to it, you can go over to Archaeology Podcast Network on YouTube and check it out. Let's get into the show. I'm going to introduce our guest through his bio right now, and then we'll start talking to him. Markus Eberl is an anthropological archaeologist and epigrapher. He has conducted archaeological fieldwork in Germany, Israel, Mexico, and Guatemala, and he currently directs archaeological projects in Tamarindito and Zican and Tzacan, both ancient Maya sites in Guatemala's tropical lowlands. In the laboratory, he specializes in soil and ceramic analysis. Recently, he acquired a dynamic image particle analyzer for his micro-artifacts lab. He now uses machine learning to identify human-made artifacts in soil samples. His book publications include Community and Difference, Change in the Late Classic Maya Villages of the Pateks-Butan region, 2014, and War Owl Rising, 2017. Okay, now that we know Markus, we'll introduce him. Markus, how's it going?
Perfect. Thank you so much for having me on your show.
No problem. So, yeah, Markus is fresh in from the field, like literally a few hours ago as we're recording this. So we appreciate you coming on and recording this interview with us. But what led you to us was an issue in Advances in Archaeological Practice that we will link to in the show notes. And the title is Machine Learning-Based Identification of Lithic Micro-Debitage, which just sounds super cool. So I'll kick it off with a question here. And we'll get into a bunch of other stuff, but you mentioned right in the beginning of this article, slow data. And honestly, I don't think that's a term I had heard before. So what do you mean by slow data?
I think as archaeologists, we all tend to work for long periods of time at the same site where we really produce very deep and rich data about this specific location that is really contextually very important and super rich. And of course, where we spend a lot of time interpreting it. Mm-hmm. But from my perspective, and I think many others, we also realize that it's very hard to generalize from this data set to patterns that are broader, larger, where we can say, oh, this is something that is not only happening here locally, but where we can look at patterns that are visible on a much larger scale. And again, I'm not critiquing slow data. I'm just literally coming back from the field where I'm producing slow data. But what I try to do in this paper together with my colleagues is to point out how we can complement the slow data with other approaches that include, for example, machine learning.
So why machine learning in particular? You have an interest in it, obviously, but what makes you gravitate toward it?
So as we explain in this mouthful of an article, my interest was in a lot of understanding lithic, I should say stoneworking. So in the area where I'm working, the classic Maya, they never really developed metal tools as we see it in many other complex ancient societies. But they really relied on stone napping of chert, of obsidian, and possibly other stones to produce all their tools and many other implements in their life. And for me, it was always interesting to understand, well, who did this stone napping? How did they produce their stone tools? And this brought me then to the interest into micro-debitage, because modern stone nappers tend to get rid of their debris that they produce during stone knapping, simply because it's very sharp and you don't want to walk over it, or you don't want your children or others being hurt by it. And so actually among the classic Maya and other societies, we know relatively little about how the stone knapping actually works. Where do we have workshops? And one of the approaches that archaeologists have been toying around for decades now is the use of micro-debitage, meaning to look into the microscopic debris that these stoneworkers are producing. And the advantage of micro-debitage is that in most contexts, it's very hard to get rid of them. So unlike larger flakes that you can easily pick up on surfaces, micro-debitage gets easily lodged into floors and other areas. So this means that by analyzing micro-debitage, we can get an idea about where ancient stone mappers have been working. My interest is now, to analyze microdebitage, to recognize microdebitage in soil samples, and to find out where ancient stone knappers have been working.
Okay.
So in the past, or should I go on a little bit about how people have done this so far? Or
well, let me ask a clarifying question first. I mean, how do you define microdebitage? I read it in the article, but just so we can get it out on the podcast here, how are you defining microdebitage, and how does that debitage differ than, say, regular debitage? You know, the tertiary, primary, secondary flakes, however we identify those. Does it have different characteristics, not just size?
Yeah, so, and this is, again, and actually, I mean, I can talk about a paper in progress that I'm just writing about exactly that. So there's a lot of discussion, what is microdebitage? For this paper, the machine learning, we defined it as all flakes that are smaller than 6.3 millimeters, or a quarter inch. So this would be what would be sieved out during regular screenings in excavations. So this is more like a heuristic approach. And in the paper that I'm right now writing, I argue that probably a tighter definition is warranted. But at least for the key idea is that this is the stuff that falls through our sieves when we are excavating and looking for artifacts.
Okay.
Now, one of the other aspects that you mentioned, this is one of these critical ideas that microdebitage supposedly shows the same characteristics as regular debitage, like, the conchoidal fractures. And this is, again, one of these issues that I can come back to, where I got a little bit skeptical looking at microdebitage, because for me, it's much, much more variable than the regular flakes that we would pick up from a stoneworking workshop.
Why would that be? Why is there so much more variability?
I mean, one is simply the size. So what we did is we work with modern stone knappers. So we go to knap-ins, and for this particular paper, we work with a good friend of mine, Michael McBride. He's like reproducing stone tools. So we asked them, could you make a biface or arrowhead, whatever you want to do, and can we collect your debris? And most of the stone knappers that we approach, they are super happy. I mean, for them, it's just, it's debris. And so they don't really care about it. But for us, for my team, it's really super interesting to collect all these thousands, if not tens of thousands of particles. And what we then do, and I can come back to that, we run all of these particles through a particle analyzer. So this is a machine that allows me to take photos of all of these particles and describe them in various ways. And the interesting part, to bring it back to Paul, to your question, when we looked at the variability, like, simple dimensions, how long is each particle, how wide, what is the transparency, angularity, it turns out they don't fall in this clear, like a tightly defined class that we would expect. But instead, there is a huge variability. And this is one of the issues that makes dealing with microdebitage so difficult. They're much more variable than people previously assumed.
And is microdebitage that you've derived from human activity, from flint knapping, is it statistically different? Is it significantly different than other little stone bits you might find? I mean, are you able to determine that?
And this is exactly where it becomes really interesting, because what we did for this article is we compared the experimentally produced microdebitage to a regular soil sample that I picked up many years ago during my dissertation in Guatemala. And I should say this soil sample contained all kinds of stuff. So, like little plant twigs, little ceramics, whatever was, what you would find in a soil sample. And so what we did for this article is to compare the experimentally produced microdebitage to this other, so which contains not only rocks, it contains sand, twigs, and whatnot. And the interesting part is statistically, we applied not only the machine learning algorithms to these two samples, but we also ran statistics. And one of my graduate students is writing a paper about that. And we can show that these are statistically pretty different. There is some overlap, but overall, if we look for specific dimensions, we can really differentiate between these two categories very nicely.
Okay. You mentioned when you first started getting into this that, people have tried to study microdebitage in the past. Aside from, your approach of using, these tight scanning methods and machine learning to suss this out, what have been some of the past approaches to this?
So, that's what I tried about 20 years ago when I was dealing with my dissertation. Because, I was working at a really interesting site in my area, and my mentor encouraged me to look into soil samples. And I was like, well, that would be really interesting, because we knew that there was a stone knapper working at this particular location where we excavated. And so I used the microscope that we had in the lab. And what I did was the traditional approach of analyzing soil samples. So I think I had about 50 soil samples, and I sift them into different size fractions. And then I looked at each size fraction under a microscope, hoping to find, what is soil and what is microdebitage. And this experience, it was super tedious. Literally, I spent hours and hours just looking through a microscope at soil samples. And ultimately, this experiment never made it into my dissertation, because I really questioned myself, After looking for hours and hours at the same soil sample, I was like, do I really see that? Or am I just imagining that this is a tiny flake? Or is this really just my own imagination speaking? And, just to give you a few numbers, what I didn't realize at that point with the particle analyzer, I regularly find 300 to 500,000 particles in a soil sample. So this is literally less than a handful of soil. And now you can imagine, the idea would be, or the ideal for an archaeologist would be to look at each of these hundreds of thousands of particles and say, this is soil, this is microdebitage. And at least for me, this is where I became skeptical, where I said, I can do this for perhaps 100, 200 particles, but to really scale that up to 500,000 or even millions of particles, I said, this is, at least for me, I couldn't say that this was what I could really get a quantifiable result out of that.
Wow, that's really cool. Well, why don't we go ahead and take a break? In the meantime, check out ArchPodNet.com/members to join us for our next Cultural Share event and see all the other stuff that we have for you. Back in a minute. Hey everybody, Chris Webster here, just with your quick break between these segments of the ArchaeoTech podcast. We have a membership site, ArchPodNet.com/members. On our regular podcast, and soon to be here, you might be hearing some ads. We get rid of those if you join our membership. So we get up to a certain number, we won't have to do that anymore. So ArchPodNet.com/members, you get access to a private Slack team where you can talk to other podcast members, podcast network members, and the host of the show. And you can talk about whatever you want, not just the shows. And then you can also get our bonus content and any live shows we have that are free usually. We have that on the back end for you to access anytime you want. And anything else we have. $7.99 a month, or I think $76 a year, give or take. All right, back to the show.
Hi, welcome back to the ArchaeoTech podcast, episode 207. Today we're talking with Markus Eberl about a recent article of his about computer vision and lithic micro-debitage. And Markus, just before we went to break, before we got a little glitchy there, talking about some of the shortcomings of doing this kind of work with a more traditional manual process of using a microscope and counting particles by hand, so much so that you gave up on that initially the first time through with it. So aside from just being slow and maybe inaccurate, are there any other major shortcomings to that kind of more traditional approach? And how do you address those with the computer vision approach?
Yeah, well, thanks for asking that. I mean, I think another shortcoming is also like the inter-observer error. So like if I want to train other people to do this type of analysis, how well will different people see the same thing in the same soil sample? And again, I mean, I have colleagues like Isaac Ola who really train than other observers, but this has been a problem in the past. How do we really get a standardized observation that different people see and classify the same things? And I think especially with micro-debitage, we easily run the risk of that different people see different things and count different things.
Another thing I was interested in what we were seeing here is how the ground surface influences the accumulation of microdebitage. Like if you've got a really smooth, clean surface, I mean, you can tend to sweep all that out and not have anything. Whereas if you're just on the ground, and you've got more crevices and things. So just tell us a little bit about that and your experience in this collection and what you can find.
I mean, this is another really critical aspect. I mean, for example, in the area where I'm working with classic Maya, the upper levels of society had the nicer houses, often with very smooth stucco floors. And a colleague of mine did some experiments with microdebitage, and she found that very little actually stuck to the stucco floors. I mean, they were very hard, and you wouldn't really expect to find microdebitage in whatever crevices you have there, because the surfaces tend to be too dense and too smooth for like a good analysis of microdebitage. On the other hand, the area where I'm working, so as a Maya archaeologist, I tend to specialize on the non-elite section of the population, where we have mostly pebble floors, possibly filled with packed soil. In these types of environments, microdebitage tends to stick much better. I mean, so we have here like areas that couldn't be where you could clean the larger flakes off very easily, but I think where people would struggle to clean off microdebitage because it's really it's sinks into the soil.
I mean, 2 points on that. First off, I mean, just in our own society today, I mean, you tend to see that. I don't know how to say this in any way that's not PC, but certain levels of society tend to just have more things around anyway and don't clean up as much to begin with, right? So I have a feeling that that's probably similar in other cultures. And along those lines, what are the chances the people in the elite, of Maya society in particular, are even flint napping and not just having things created for them?
I mean, that's actually really one of the aspects that I and my colleagues are really interested in, because at this moment, we don't really know. I mean, again, it makes sense what you say, like, oh, if you're like a lord, I mean, you won't be napping your own things. But the point is, it's really hard to prove that point. And that's what I find fascinating about archaeology in general. And this approach in particular, I mean, I can go back and say, if I work in a palace, do I have any evidence of microdebitage, or is there a potential that, a few stray flints are still visible? So for me, it's more like a question to be asked instead of assuming, okay, people at that level, they don't care about napping chert or whatever. So, yeah.
So a traditional method of trying to identify workshops would be looking at larger flakes, for example, or could be across any variety of different kinds of artifacts of any kind of workshop that you're looking at. But obviously you'd be looking for lithic flakes if you're looking for these flint napping workshops. In absence of larger flakes, is looking at the microdebitage, is that a reliable indicator of workshops?
And we have, and this is going to be an interesting discussion in the future. So for some researchers, they would like to see both, meaning that we have here microdebitage and we have some kind of evidence, like visible evidence for a workshop. That could be, of course, larger flakes, but this could be also like specific other tools that were used for flint knapping. That could be a specific layout. And I personally would veer more towards that. I think clusters of microdebitage can be very useful, but I would like to see, additional evidence. For example, in the area where I'm working, these are larger residential groups with multiple buildings grouped around the plaza. And it would be great to see like elevated concentrations of microdebitage in specific areas of this group. But I would like to see additional evidence. For example, do we have other types of tools that we find, for example, in the middens of this group that would point out, oh, we have here very likely a stone knapper who is working there. So for me, again, as I said, I'm not against slow data. So, I'm perfectly happy to do an extensive excavation, look into middens, and then to really use, for example, my microdebitage analysis with machine learning to complement that with my excavations of middens and others. And at least that's my gut feeling right now.
Man, I got to go back to this elite thing real quick because first off, I love how much a simple question can actually put a lot more things into play, right? It just leads you down this path because I'm thinking, okay, so if they are flint knapping and somebody's cleaning up after them, right? Whether it's them or somebody else cleaning up after them, you think you would see some sort of common place that they would sweep up all this debris from inside the house, dust, skin, lithic debitage, whatever it is, and then dump it in a place. So now you're getting to where's their trash collection for this, elite place. And could you analyze that to see, well, in this, what looks like household trash, we have micro-debitage.
No, you're absolutely right. And the problem often is, so there have been several archaeologists who did like experiments or ethno-archaeological studies. The problem with this that modern stone knappers, and I say stone knappers because in the area where I'm working, people would be both using flint and obsidian. So these stone knappers, they often go out of their way to dispose of the trash. So it's not something, where you simply, where you just walk behind the house and you see, oh, there must be the mitten and, this is where I have to excavate. At least in some of these modern cases, stone knappers really knew, they wouldn't have their family handling these sharp debris, and they really walked like hundreds of meters away from the area where they were working. So in the sense, that would then add the challenge, as an archaeologist, where do I find the trash, and especially the workshop trash? It could be a different place than where they would put the kitchen debris, all the vegetables and fruits that were thrown out.
Okay. I think maybe we should get into the part of the actual title of this with the machine learning stuff. I'm interested because you mentioned 20 years ago you're interested in microdebitage. You're looking through a microscope at soil samples and you're figuring all this out. So presumably you've been thinking about this throughout, and it's been one of those things that's just kind of like plaguing your mind. When did machine learning become viable enough for you to look at it and start saying, you know what, this could be a tool where we could actually solve this problem? Is it with this paper, or was it the genesis of that a little bit earlier?
Actually, it goes back a little bit earlier and really started with the particle analyzer. And this was, I don't even know what got me there, but this was like a late night Googling accident because I was always interested in different ways in which I could describe a flake. Like how could I get like quantitative data on a flake? And as I said, like some Googling accident late night brought me to particle analyzers. And just to explain that, like these are machines used by modern companies for like a quality control. So the company where I bought this machine from, they told me, oh, they sell it to glass bead manufacturers. So where people have 10,000 glass beads and they want to know whether this run of glass beads is exactly, according to whatever specification. So they were actually super surprised and delighted to have an archaeologist knock on their door and say, oh, this is exactly what I want to use for my work. And this was really the thing where I realized, the company invited me to send them 2 samples, to test the capacities of their machine. And when I got the results back, they sent me 2 Excel spreadsheets. I realized, okay, I'm in trouble because this is more data than I really expected. I mean, they couldn't even send me a spreadsheet just as an attachment. I had to go to like Dropbox or a similar service because they were so large. I mean, there were like tens of thousands of particles listed there, and each particle I have like 40 variables. So this is then where I realized, okay, I'm into statistics and I can handle that. But just looking at the spreadsheet, I realized, this seems to be like something where machine learning or computers in general could do something really interesting. And I then linked to the data scientists who are the co-authors on this paper, who were super delighted because for them, this was the ideal data set that they have been looking for, like exponentially produced data where we know what something is. And then you just try to see this specific class in a different data set. So they have been amazing, and I've been working with them for the last 5 years. And this is really where the machine learning then took off because they said, this is a perfect data set to apply machine learning algorithms. So in many ways, as an archaeologist, I really stumbled into it. And through various colleagues, I really got into machine learning, but it's really like this coincidence of various factors that brought me to this topic and into machine learning.
Nice.
Well, that's fun. I kind of like that. Yet again, archaeologists are picking on some other industry, in this case, industry, to find tools that we want to use. I always joke that our the symbol for our field is a bricklayer's tool, not even not even something of our own.
Exactly. Now let's talk about the machine learning aspect of it. Actually, you know what? Before we get there, I'm curious because you said a small sample that you sent this company, and they send back tens of thousands of results. What is the smallest particle that their scanner can actually find and suss out and identify? And then I've got a follow up to that one related to the debitage. So that first.
Yeah, so this machine that ultimately, with the help of my university, I was able to acquire, measures everything between 35 microns. So this is what 0.0035 millimeters and 35 millimeters. So it really covers a wide range. And, for the micro-debitage analysis, I limit that. So I filter out all the smallest and the largest particles. So I limit that to 0.125 millimeters to 6 millimeters. So theoretically, this machine could measure much more. I also have to filter it out because when I got the machine for the first time, I had no clue and I was just playing around with it. And the machine several times broke down because when I just used the entire range that it can measure, I literally ended up with millions of particles. Specifically because I have tiny clay particles that just that create tons of data points.
Yeah. Wow. I mean, I guess that would be expected. That led to another question. I was going to ask how small you can call something micro-debitage before it starts becoming, potentially natural. You know what I mean? How do you even know it was human created when you're getting that small? Yeah.
Exactly. And this is exactly, where I'm really working through these issues because exactly as smaller it gets, the rounder these micro-debitage particles become, and they are very, they become very hard to distinguish from regular sand kernels that you have in soil samples. So this is really one of the issues that I'm working on right now, where I say if you go too small, it becomes very hard to distinguish between these two categories. And it doesn't make sense to call very small particles micro-debitage because it's really hard to distinguish them from regular soil particles.
Yeah, I'm sure they experience erosion much faster too. The edges get knocked off, things like that, just because of their size, I would imagine. Yeah.
Exactly.
So,
yeah.
All right, well, let's take a break. And on the other side, we'll wrap up this discussion and maybe talk a little bit more about the algorithms and the actual methods that you guys use to do this. So we'll do that. In the meantime, I'll mention once again, check out archpodnet.com/members to become a member of the Archaeology Podcast Network. We've got a Kelturo Share event coming up. That's the Sunday after this podcast releases about underwater maritime archaeology. So check that out. If you miss it, you can watch it if you're a member anytime you want. We'll be back in a minute. All right, everybody, one more time, archpodnet.com/members. Go check it out, and you can help us out and keep these shows going. Welcome back to episode 207 of the ArchaeoTech podcast, and we are talking to Markus here about this paper that is linked in the show notes, so go check that out. I won't read the whole thing out again, but we're talking about micro-debitage, machine learning, and figuring all this out. So, Paul, you had a question to bring in on this side.
Yeah, I did. I was curious. So, Markus, you were saying that size is a great filter that you use once things get too small. You don't want to count them because they're unreliable. And part of that is that they become rounder. Are there other thresholds that you use about the shape of the particles that you can use to filter, or is basically size and roundness the main one?
Actually, I mean, for the moment, and this is really like the ongoing project, I'm still trying to figure out, what are good characteristics to identify microdebitage. So just to repeat one aspect, this particle analyzer that I'm using measures about 39 variables. And I say about because you can turn on specific measures and others. But so you have a lot of variables to play with. So you can look into angularity, different types of length, width, and so forth. And this is one of the aspects that I'm trying to work through right now to answer seemingly basic questions. How do microdebitage look like? And how can I identify it in statistically useful ways? And so currently I'm still using basically all these variables, and we are just like focusing on a few, like for example, in this particular paper, transparency came out as the key variable, which probably for archaeologists who look at flints or like bifaces is pretty obvious, I guess, because normally flakes are relatively thin. So light shines through them. And the same applies to microdebitage. So for our machine learning algorithms, transparency was by far the key variable. Others came in, but this is also where these different algorithms then differed, which type of variable they preferred. But as I said, transparency was really the one that stood out among all four algorithms that we compared.
That's really interesting to me because you've got in the article, you used a handful of different algorithms, right, to these machine learning algorithms. But in order to make a machine learning algorithm smart and give you the results that it's going to come out with, you have to teach it. But if we don't really know, if you guys don't really know exactly how to characterize one of these microdebitage flakes, what kind of material are you giving the algorithm to say this is right and this is wrong?
So what we do is, and this is why the data scientists on the team were so delighted, because we have experimentally produced microdebitage. So basically, what we gave the machine is, okay, this is a sample of experimentally produced microdebitage. And this is what you have to as a training material. So this is how microdebitage looks like. And then we give it the archaeological soil sample and say, okay, where can you find this microdebitage in an actual soil sample? And can you figure out, are there similar particles in this soil sample? So this is the key part, that we have an experimental sample that can be used for training, and then we can apply it to an actual soil sample.
I'm imagining somebody napping in like a radiological suit in a clean room or something like that, so you don't contaminate it with anything else.
I mean, in our archaeological way, I bought like one of these 20 by 30 feet tarps, and we put it up in a small room. And the flint knapper was then working diligently in front of the tarp, and we just folded it up and put it all into Ziploc bags.
You mentioned earlier flint and obsidian, and we're talking about the training group. How much variability do you have between different kinds of stone that would be used? Because I can imagine that might be significant between cherts and flints and obsidians and whatever else people are, quartzite, whatever else they're mapping.
And this is again, like in a short, I would have to say we don't know, because like people have always assumed, as I said before, with the manual approach, that every micro-debitage particle should look like a regular flake. And nobody has really studied differences, for example, in material, I'm just getting into that, is obsidian the same from flint? Are different sources of obsidian, do they produce the same type of debitage? So this is really what I'm really starting to throw the statistics out to see whether we can see these differences or whether they are really similar. But yeah, it's again one of these simple questions that lead down a rabbit hole of, well, we don't really know. We have to jump into that and look into different sources, different raw material sources, and compare.
I'm also imagining different workshops using slightly different techniques or different tools might also affect that.
Yeah, and to add that, I mean, for example, I have a graduate student who's interested in gender differences. I mean, I don't know whether you ever went to one of these snap-ins. I find them fascinating because they are basically 95% male. So this is often also what we think, when we think about stone napping. Okay, well, these are male stone nappers. But again, do we really know that? And so I have a graduate student who looks for specifically female stone nappers to collect their debris to see whether she can find, for example, different differences among the debris of male versus female stone nappers. Again, an issue that simply hasn't been studied, and I'm looking forward to see that, like whether she finds something.
Yeah, it might be, not to be too on the nose, but literally microscopic differences between male and female, but that the algorithm could suss out. Yeah. It had to be said.
What we also do, we do interviews with modern stone nappers. And for example, we had several male stone nappers who say, female colleagues that they have, they can put as much pressure on the stone. So, from again, this is not quantifiable, but anecdotally, they say, oh, there are differences how male and female stone nappers work. And if we can quantify that, I mean, that would be fascinating.
Something Paul said earlier made me think about another thing that could be looked for during this process. You mentioned different workshops, different tools. Obviously, there's different things used to make stone tools, right? You've got antler, you've got bone, you've got other rocks, things like that. Are you guys close to analyzing? Because those are going to break up as well, and you'll produce micro bits of debris from those. So are you able to find some of that in your samples, or are you looking for that kind of stuff yet?
Not yet. I mean, but you bring up a really good point. I mean, different napping techniques. So another thing that we are working with modern stone nappers is to ask them, well, or what we do is we record the specific tools that they're using. And we also ask them, could you use an antler instead of like an ishi stick or whatever they're doing?
Yeah.
And that's for us really a critical part. Again, something that has not been studied. The other aspect, that's a really good idea. I mean, I haven't really thought about, antler debris that could end up in a soil sample. Yeah, I mean, it's possible. I mean, honestly, I haven't looked into it, so I don't know.
Yeah, there's so many directions this could go. Really, it's pretty interesting. Bringing this all together, and I know you're really in preliminary stages on figuring out what we can actually find out from all this stuff. But and we talked about this a little bit in segment 1, but really, what have you learned from some of the things you've analyzed by studying microdebitage that you wouldn't have known otherwise about a site or about, a technique or something like that? What is this really telling you that's different from other techniques?
Well, I mean, one aspect is simply that I see a path forward to analyze hundreds or even thousands of soil samples. So the traditional manual approach has been really limited in the sample population. I mean, I think, I did a review of the literature. I think the maximum number that I saw is about 160 samples. So people have been really dealing with like often just a single room in a building or like a residential group. But it has been really hard to use microdebitage analysis, at least the traditional microdebitage analysis, on the level of an entire archaeological site or even like a region. And that's really what I'm getting very excited about. I mean, one of my previous graduate students, we are still collaborating. She, for example, took soil samples from an entire archaeological site in the Maya lowlands. And we are now still, I mean, these are now 500 and something samples. So we are still in the process of looking through them. But this is for me the first where I can say, okay, we can probably talk about how stone napping looked like in an entire ancient city. Do we have different neighborhoods of stone nappers? Did they work with different stone materials to not compete with each other? And so they are really, for me, fascinating issues about the ancient economy of stone napping that previously could not be answered. And so that's what I'm really getting excited about, to scale up this particular approach and hopefully get insights into like larger economic patterns in ancient societies.
As we're wrapping up here, anytime somebody comes up with an efficient way to do something and you bought the equipment, you have the particle analyzer, and you're developing the algorithms for this. Since this paper came out not too long ago, have you been approached by anybody else to say, hey, can you analyze my soil? Can you do this? You guys might be setting up a business here.
I'm not yet there. No, but I'm getting really, I mean, people are getting really fascinated by it. I mean, and I should say, I mean, I'm also getting requests from archaeologists who suddenly hear about the machine and have completely new ideas. For example,
Sure.
a colleague in my department, his wife works with, she's interested in the development of maize, corn across time. Yeah. And so she, for example, excavates middens where she has in different layers, like from thousands of years back until more recently, different charred maize kernels. And so she asked me whether she could run these hundreds of maize kernels through the particle analyzer to study how the individual kernels, how they differ in size or dimensions across time. So the point is, you can apply this particle analyzer not only to microdebitage, but, you can come up with really interesting new ideas about how to look at archaeology. So, yeah, I mean, I assume that there will be more people knocking on my door and asking about that.
Could be an easy way to fund your research.
If we would be that wealthy, I mean, as archaeologists, our funding limits.
Indeed. Well, where do you go from here? What are you looking at next without giving away any papers or anything that are in production? I mean, what do you hope, what kind of questions are you hoping to answer after this?
So one thing is really that we try to nail down quite a few of the questions that you just brought up. I mean, for example, is microdebitage the same across different raw materials?
Sure.
Do we see differences among male, female, or stone nappers, let's say, in the experience? A stone napper who has 5 years experience versus a stone napper who has 20 years of experience. So we really, my team, and I should really say it's a team. I mean, it's not just me. I mean, there are graduate students and others who are working on that. We're really trying to answer these questions through this part. So this is really one of the biggest hopes to find answers to these questions. Another thing that I'm actually what I did this summer, I mean, I came back from Israel. So for example, I'm also using the particle analyzer to study ancient mortars. So we got an NEH grant to look into the different components that ancient peoples put into mortars. And so I collected mortar samples, and now we started already to run them through the particle analyzer. And we hope to be able to find out how mortars from different cultures differ in the composition of their mortars.
Nice. That's really cool.
In Iraq, Chris, well, I've been working there for the last couple of years. And one of my colleagues is doing all sorts of soil cores, looking at environmental change and the advance in the retreat of the waters there. And I could see this being maybe a way of, he looks at very small faunal remains to tell us what kind of environment it was. And I could see this set of tools being a way of looking at finer grain changes between one layer and another than he can currently do, just because it's too slow to do it manually.
No, I mean, and if anybody's interested, I mean, you can approach me. I mean, people can run their samples and go with it. I mean,
Yeah. Awesome. All right. Well, this has been super fascinating. I hope we can follow you on this and really stay on top of some of these changes. We've talked about machine learning. We've talked about, AI and doing some stuff like that before. And a lot of it is really fascinating, but this really kind of hits one of my sweet spots, as a cultural resource management archaeologist out here in the West of the United States. We deal with a lot of lithics, and sometimes, we're on a site and we're like, oh, okay, so we found like 20 flakes. That's pretty much it. Here's the story of the site. When in reality, there's 200,000 micro-debitage flakes because somebody already picked up the tools. Somebody already even picked up some of the flakes, and the real story of the site hasn't been told. I think that's just super interesting from a management standpoint. We say the site is not significant because we didn't find anything big, but what about all the small stuff that could really tell you about the site?
Yeah, I'm looking at it with interest because it's not about the tech, it's not about the stats, it's about how those are being used to analyze what people did, which is, as anthropological archaeologists here, that's really what it's all about.
Absolutely.
Yep.
Yeah.
Exactly. All right. Well, Markus, thank you. We really appreciate it. And always feel free to come on the show when you're, ready to talk about some more fascinating tech stuff that you guys are doing and or to just chat about what you're doing.
Thank you so much. Thank you for having me.
Thanks for coming on. Take care. Thanks for listening to the ArchaeoTech podcast. Links to items mentioned on the show are in the show notes at www.archpodnet.com/archaeotech. Contact us at chris@archaeologypodcastnetwork.com and paul@lugal.com. Support the show by becoming a member at archpodnet.com/members. The music is a song called Off Road and is license free from Apple. Thanks for listening.
This episode was produced by Chris Webster from his RV traveling the United States, Tristan Boyle in Scotland, DigTech LLC, Culturo Media, and the Archaeology Podcast Network, and was edited by Chris Webster.
This has been a presentation of the Archaeology Podcast Network. Visit us on the web for show notes and other podcasts at www.archpodnet.com. Contact us at chris@archaeologypodcastnetwork.com.